Hey, welcome to the video tutorials on data wrangling in PumasCP. We'll continue with the core transformations. Here we are highlighting how to do derive operations and defining new root or defining root of administration column in the dataset. In the previous videos, we have used PC and EX datasets to as examples. Here as well, I'm using the PC dataset to show you how the derive column works, derive function works, and you need to open the file code transformation derive and define from the list. And here you can click on um, the transform icon in the PC dataset because this is the original file. This is not a derived one, so I'm transforming it for the first time. So click on transform to open the data wrangling wizard. Here in the code transformation, you will see an option called derive. So derive is used to add a new column. So it can create new columns by can perform calculations or transformations on the existing columns that you have in your dataset. So I click on derive over here, and as I was mentioning, you can apply any mathematical operators, be just simple addition, subtraction, multiplication, division, or use inbuilt functions to transform the data. Like examples in the documentation, if you see, let me bring that screen over here. So in the documentation, you might observe that there's so many inbuilt function we have in Julia. You can use all these uh, syntaxes, all these functions in the derive function over here. So these are the list of examples that you can use, uh, and you can click on the link to in the description as well in the video to reach this page. And let's um, look at the function in here in this particular uh, wizard. What does the function tell? What all input we need to provide? So here, the new column name that I can enter the existing column name or provide a new column name over here. So if I write an existing column name, it will replace the current column. If I write a new column, it creates a new column, keeping the original columns as it is. And one more thing, if we observe over here, there are two ways to create new variables in the dataset, either by using the row-wise method or by using the column-wise method. Row-wise, this method looks at one row at a time and uses the data in that row to calculate new values. And these new values are then stored in the same row but can use information from different columns within that row. And column-wise method looks at one column at a time, either in isolation or by grouping similar entries together. It calculates new values based on the data in each column. These new values are then assigned to the appropriate rows within that column or a new column, potentially affecting multiple rows at once. The We will look at different examples of how by row and by column functions work. Let's take a simple example for first. Uh, I'll create a column called, mm, let's say, drug, and then I want in this new column the same values as um, PC test. So PC test column, whatever values is there, I want the same values in my drug column also. So what I can do is I can write the colon symbol and tell the column and call the column name as PC test. So here you see that now a new column is created on the right hand side of the dataset called drug, and the same values are pasted which was in the PC test column. This is one example that you can create new columns using the existing data. So let's look at a different example wherein you can create a column by taking um, a substring from another column. Again a very simple way to do this. Let me just close the function that I just performed, and click on Derive again. Here, um, provide a new column name, say it as a period. So I want to create a column called period, and I have my visit data, I guess. Yeah, I have the visit column over here, and I have the period and day information. So here you see that I have combined data, period and day in a single column with numericals beside the text. So this is a string column, and you see after period 1 there is period 2, like that for period till period 4 in this particular data set. Um, I I'm interested to just get this value in all the rows. So to do that, I can use a simple split function and say I have a visit column, and in this visit column there are spaces in between each characters. That is, let's say between period and 1 there is a space, and between 1 and day there's a space. So I'm using the space as a delimiter to differentiate between the characters and say I want the second character from this split uh, function. So here, if you observe, there are four different characters we can clearly see. That is, period is the first one, second one is the numerical of period, day, and there is the day as a numerical. So I'm taking the second part of it, right? So if I just scroll to the right hand side, you see that a new column now has been created called a period, and it has taken the second value of the text. So same way you can do, so you can just say 3, and now you see that uh, all the day text is now passed. So it's just taking third part of the uh, string. That's it. It's a very simple way to extract information from the existing data. I will uh, close this function again to um, select few columns. This has around 19 columns, difficult to visualize. Let me keep it simple so that you all can easily understand of what is going on. So let me have subject ID, maybe PC test, and visit, and visit number, PCDTC, PCDTC number, and yeah, I think these columns are sufficient. So this is a very subtle list. We can easily view what changes are happening. So you can also using the derive function, you can also generate columns based on conditions applied to other columns. So how does it work? Click on derive and say I want to create a new column for NRRLT, nominal time related to the last dose. And here I can say using the PCTPT num column over here, the last column, I'm using this column as a reference. If this column value is less than 0, then give a value of 0, else keep the values in PCTPT num. Don't change it. So that's what I'm seeing over here. Just move to the second line. So I'll repeat this part. So here, the first part is the condition, that is PCTPT value less than 0. And this is again an operator to say if this function is true, then give a value of 0, else give a value of uh, the second part of the function. So if I write say 3 here instead of PCTPT num, you see that all the values will be 3. So um, I can keep this as PCTPT num itself to make to get the column as in RRLT. So here, if in this particular function, you see that based on the condition that I provided, and using a different column, I'm creating a new column for expanding the data. and these the question mark symbol and the colon symbol are called ternary operators, and as I said, it takes three operands: um, the question mark, the colon, and the true or false conditions. So in this way, you can easily perform different create in fact create new columns. Let's see a simple example again. Let me uh, let me add the a period column that I had previously also. Let me say split um, visit and take the second part of the function and say this as a period. So here I created a column called a period, and you see that it is a string variable, and the value column contains all numbers, and I want this column to be converted to a number or a float in terms of so what I can easily do is you click on derive again and say the new column name is a period f. I'm changing the name just to make sure the same column is not replaced. So I can use the parse function and say that this column, whatever I'll be providing as an input, needs to be converted to a float. So float is nothing but it can be denoted in simple terms. Float term is used for numbers or real numbers, you can say, and integers, can be used for whole numbers. Here, I'm I'm saying that uh, I created a new column. I'm using the parse function to convert the a period column to a float or a number. You see that a new column now is being created with type of column as number, and in this way you can uh, convert columns as well, not only apply mathematical functions or operations. Um, Continuing with mathematical operations, let's also perform one more simple uh, mathematical operation on this. Let's say I'll create a new column for NFRLT and say here that using the NRRLT existing column, um, add this column data with 24 into 7 um, into column A period F minus 1. Just move this to the second line so that you all can visualize easily. So I'm using here, you see that I'm using the NRRLT column and the A period F column to create a new column called NFRLT. And and in this way you can use multiple columns to create a condition and create derived columns using those. So this is nominal time related to first dose is generated based on the other two columns here. And the same way you can use perform different mathematical operations. And here, one more important thing that you can do is convert date times as well. So here you see there's a column called PCDTC, and the values here seems to be like a date and time, correct? The first part of the value is date and second part is time. So, and it is called as a string, but I want this to be converted to a date time variable, correct? So I can use the derive function again and say I can call it as ADTM, the new column as ADTM. I can use the date time function and use PCDTC as my reference column and say how's the string is structured. So here the string is structured in such a way that the first part of the value is year, month, date, hours, minutes, and seconds. So same thing, I'll write it over there. So it should be double y, and you have after the year there's a hyphen symbol. So just type hyphen month and date, and there's a space between date and the hours. So I'll provide a space, and then I'll write hour colon minute and seconds. Now it reads the string variable that was there in this column and creates a new date time variable called ADTM. That's what I called in the derive function. You see that now a date time variable is created based on the input that I provided, or the reference that I took. This way you can extract the or convert the string column to a date column if you have the values in that particular column. You can also, let's say now you see that there is a date time column, and that is combination of both date and time. Let's say you think, oh, I don't need the time, I just need the date from this column. So it's again very easy to do. I can create a new column, clicking on derive again, and say this as ADT. And here I say that just give me the date of whatever is present in ADTM column. Now you see that new column is created, which is just the here the date have been extracted from the date time column and being placed over here. So this way I can extract dates. If I just replace this date with time, I can extract just the time. So I need to change this as ATM, and you see that now uh, time column is created, just extracting the time. So this way you can, instead of writing date time, combining both, you can have it in both separate columns as well. So till now, we have used the by row function itself. Let's look at one or two examples. How do we use the by column function as well? So let me just uh, close this, delete some, cancel some functions to make it simple again. I will have, yeah. So these are my 6 columns that was initially there. Make sure you uh, also cancel those so that you can visualize the changes. Um, I can click on derive and say, let's say you want to create a event ID column, correct? And if you just enter 0 over here, and you see that a new column has been created with values equal to 0. You can, this type of derivations you can easily do either with by row or by column. The result does not change. So how important by column is? I'll show you a different example where that is of utmost important. So I'll close this event again and now create, let's say, a new column, derive again, and then say maximum value of the column PC stress n. So I don't have the PC stress. I'm so sorry. So let me just go to the select columns option, and in the drop down, let's select PC stress n also included. It was unchecked previously. I'm checking it to include that as well. And let me just close this to run. Yeah, now I got the PC stress n column over here. Now I can click on derive and say create a new column called max PC stress n, and here I can say maximum value of PC stress n. Now a new column is created with maximum values of PC stress n. But you observe that PC stress and column values and the max PC stress and values are almost similar. There's no change at all. That is because I have selected this as by row. If I change it to by column, you observe that the max PC stress and the maximum value in the concentration column is pasted in this row. So generally, when you want to normalize concentrations, all those, this will be very helpful to get that. So this value 611.25, this is for the entire data set. Let's say if you wanted to just get it for um, each subject instead of the entire data set, what you can do is instead of, I'll just close this derive function and come back to the previous step. I'll do a group by function, choose column as subject ID and leave it as it is. Now the grouping has been performed based on each ID. And now if I do derive and say max PC stress n, the concentration column, and take the maximum value in PC stress n column, and you see that, and let's select by column as the option over here. You see that for each subject, it has searched for the maximum value in the species stress in column and it has pasted over here. Just scroll down to show you different subject and easily identify. Yeah. So this is subject ID 2. For subject ID 2, the maximum concentration is 192. Subject ID 1, it was 385. So this way you can use the derive columns. Either you can create new columns or you can mutate existing columns by specifying the column name as the if you want to mutate the existing columns, you can specify the old column name itself, and new name will provide will create a new column. And yeah, and this way you can perform different operations. And there's one more small thing that I wanted to show. You can in the let me click on transform again. I can click on derive and say root. I can create a new column called root and say this is extravascular. I'm just making it up. And you see no, I need to provide this in double quotes because it's a string variable. So you see a new column now is being I'm so sorry. So new column has been created with PV being printed on all the rows. I can do this way to create a new column for root, or I can use the function define root here and choose the root of interest of this particular study under the protocol. I can choose if it's extravascular or IM or oral or IV. So I can just select IVO just for now, and you see that now new column is created IV. So instead of writing using the derive, you can also use the define root function to get this sorted. Yes, so I hope this derive and define functions helped you and understand more about the data wrangling aspects in PumasCP. Please stay tuned for more videos and thanks for watching.